Okay, Calc BC, section 4.3, office hours. This is the assignment, a little tweaked from what was on the original note sheet. Talk about. So hopefully you checked your odds. I'm going to go over these, some of them quicker than others. There's a little bit of review of kind of a little everything we've done. So first one, it says to plot each point with a given polar coordinates and find the corresponding rectangular coordinates. So graphing it's just going to make it easier to kind of confirm that your answer's right and stuff. So we're starting with part A was root 2 pi over 4. So pi over 4 would be here. And then, you're not trying to do like a precise graph or anything. And then that would be a length of root 2. So this is pi over 4. So that's the polar coordinates. Now, I bet we could, this looks like a special triangle, right? 45, 45, 90 is going to be 1, 1. So the Cartesian coordinates, the rectangular coordinates, are going to be 1, 1. I mean, we could show some work, which might be good in the future. You're not going to get so lucky. X equals r cosine theta. So that's going to be root 2 times cosine of pi over 4 is going to be root 2 over 2. Just going to be 2 over 2. Just going to be 1. Y equals r sine theta. So that's going to be root 2 times sine of pi over 4 is going to be root 2 over 2. Unity of 2 over 2 is 1. Same answer. Okay. Part B says to do 1 comma 0. So we could just do that on the same graph. Now remember, this is r theta, so the angle is 0, the radius is 1, and in polar coordinates that's going to be 1, 0 also, which is kind of a coincidence. So it's going to be 1, 0. Now if you're to use the calculations, it'd be x equals r cosine theta, so it's going to be 1 times cosine of 0 is 1, which gives you 1, and y equals r sine theta is going to be 1 times sine of 0 is 0, so you get 0. So there you go. We're going to jump to problem 3. I didn't want you to do part C and D, just to cut down the work a little bit. Part 3 is going the other way. And so we're going to start with rectangular coordinates. So this is the xy pair. I'm going to try and get the polar coordinates. It says find 2 sets of corresponding polar coordinates. So let's try and find a positive one and a negative one, a positive radius and negative radius. There are infinite possibilities. We'll try and just find the smallest angles possible. So now graphing this, let's see. Now we're going to do a quick graph. Negative 1, 1 would be right here because those are xy coordinates. And so we're trying to find the angle and the radius. So the relationship is x squared plus y squared equals r squared. So that's how you're going to find r. So it's going to be negative 1 squared plus positive 1 squared equals r squared. So r squared equals 2. You're going to take the square root of both sides. It's going to be root 2, positive or negative. Okay, so it depends on which one you choose what your angle is going to be. But if we go with positive, that's going to be one of our answers. And then we'll go with negative radius for the other one. We got to find an angle. So tangent of theta equals, now that's going to give you this right here. If we do, well, let's see, so this is negative 1 over 1, y over x. And so that's going to be sine over cosine now. So when does sine and cosine, if you put them in fraction, give you 1? So the reference angle is 45 degrees, pi over 4. But one's going to be positive, one's going to be negative. So it's going to be quadrant 2 and quadrant 4. Now, based off the picture, we know it's quadrant 2. So what would that angle be? Quadrant 2, reference angle pi over 4 would be 3 pi over 4. So that's going to be 3 pi over 4. Now, otherwise, we could go backwards over here, which you could get by adding pi to this angle. and that would give you 7 pi over 4, and use a negative radius. So these aren't the only right answers. I think these are some of the better ones to try and use, the positive radius and negative radius. Part B is 1 comma negative root 3. So this is your x, this is your y. The graph is going to look, square root of 3 is about 1.7. So it's going to be 1. And then somewhere kind of down like here, negative root 3. So that's your xy pair. So we're trying to find the angle, which could be positive or negative, and then the radius, which could be positive or negative. So we're going to do x squared plus y squared equals r squared. So r squared equals 4, square root of both sides. R equals plus or minus 2. So if we go with positive 2 for one, we could go for negative 2 for the other. So we got to find the angle. Tangent theta equals y opposite negative root 3 over adjacent. So the negative actually makes sense because that helps you zero down to the quadrants you should be in. So we're going to put these over 2. So reference angle is when the sine give you root 3 over 2 and cosine give you 1/2. That's at pi over 3. Quadrants 2 and 4, because it turns out negative. One's negative, one's positive. That happened in quadrant 2 and 4. We know from the picture it's quadrant 4, right? So we're going to go with theta equals 5 pi over 3. 5 pi over 3 if we just kind of go with the direct one. Now, we could take pi away from that to end up back here, and that would be at 2 pi over 3, and use a negative radius to flip it back to the same point. So those are two really good answers, even though there are infinite other possible correct answers. Okay, so then we had a couple just graphing these. 6 was r equals negative 3. So this is a quick basic graph. This is a circle with a radius of 3. So even though it's negative, it just means it's going to kind of go backwards. So that's a quick graph of it. I mean, positive 3, negative 3. The graph's going to look the same in this kind of situation. 7 r squared equals 4. Well, maybe you want to try and get it down to r by itself. So square root of both sides. So technically it's plus or minus 2. Okay? Which plus 2 and negative 2, they're the same thing. It's just going to be a circle with a radius of 2. So it's just going to look like this. And there's no restriction on theta, so it's definitely going to be the whole circle. So there you go. That's that one. 8 is theta equals negative pi over 4. So this has a constant angle and all the possible radii. Now, I don't know if you've gotten used to this. This is going to look like a straight line. So negative pi over 4 is here, but it's going to include negative radiuses also. So it's going to go this whole way, forwards and backwards, both directions forever. So that's that one. 9 says absolute value of theta equals pi over 6. So like these other ones, you probably want to isolate theta. So that's going to give you theta equals plus or minus pi over 6. So the graph of this is going to be two different lines. So that's like positive pi over 6, and it's going to go through the whole way. And then it's going to be negative pi over 6 is going to be over here. So it's going to be that one. It's going to be two lines. Kind of interesting. That kind of also makes sense from absolute values. We usually get two different cases. So that's 9. And then 10 is r squared plus 8 equals 6r. Well, that's kind of annoying. So I guess we could try and solve it. R squared minus 6r plus 8 equals 0. Can we factor it, hopefully? Minus 2, minus 4. Okay, good. So we're going to get r equals 2 and r equals 4. So this is actually two different polar curves. It's two circles, concentric, centered at 0. So you're going to go, one has a radius of 2, and one has a radius of 4. So here we go. Okay. Maybe be a little easier if we do this on graph here, but it's going to be just two circles, no shading or anything in between. It's just going to be two circles centered at 0. So there you go. And then we have a couple problems where we can practice changing them from polar form to Cartesian form. So we haven't done a lot of this. I think I did a couple examples in class. So this is just kind of interesting. So we're trying to change them to a Cartesian equation. Now we're probably going to be making use of, x equals r cosine theta, y equals r sine theta. So, and then x squared plus y squared equals r squared. So we're trying to get rid of the theta and r and get everything in terms of x and y. Now, cosecant is 1 over sine, right? And so then if you cross multiply, you get r sine theta equals 4, and that is equal to y, so y equals 4. That's a horizontal line, which is, again, it's kind of crazy. It says identify or describe the graph, horizontal line. So get the equation. So that was kind of interesting. 23 r cosine theta plus r sine theta equals 1. So this one's kind of easy. So a lot of times we're trying to force an r cosine theta or an r sine theta to pop up, because then you can replace that with an x, and you can replace that with a y, and then you can rewrite it in y equals negative x plus 1. So it's a line, right? Line with slope of negative 1 and y-intercept equal to 1, maybe, yes. 25 looks a little more scary maybe at first, but you might start to get the hang of, like what I said, we're trying to force those r sine thetas and r cosine thetas pop up. So if we cross multiply, we get r sine theta minus 2r cosine theta equals 5, and that's just y, and that's x, right? And then you could do y equals 2x plus 5. There you go, Cartesian equation. And it's a line. So it's a line with a slope of negative, or of positive 2, and y-intercept equal to 5. Okay. 27, last one of these I want you guys to try. So this one's cosine squared equals sine squared theta. So remember, we're trying to get r cosines and r sines to pop up. Well, check this out. If we multiply both sides by an r squared, which is just a number, so that's totally allowable, look what do we get? We get r cosine theta squared and r sine theta squared. So that's going to be x squared equals y squared. And so then if we were to solve for y, you would take the square root of both sides, plus or minus, and get y equals plus or minus x. So we actually get two lines from that one. So anyways, still fun. Okay, and then 39, this is where some of the new stuff from today comes in. It says find the slope of the curve at each indicated point. Now, these ones don't give you a picture, but I think it's really worthwhile to do a quick sketch. And you guys should be getting good at these quick sketches. So we're supposed to do it theta equals 0 and pi. So let's do a quick sketch of this graph. This is a cardioid, right? You guys, some coefficients are the same. We do a quick little table here. Just calculate a couple values. It should be kind of vertically oriented. So 0 would be -1, 0, -2, 0, and then back here, -1. So it's definitely going to be bigger in the right direction. So this is going to be, to make a little mistake here. So let's see if I'm doing this all correct. This is the right problem. 39, 0 be -1, be 0. So I don't know. I feel like there's something wrong with this. Pi, that would be, oh no, pi would be 0, so that should be -1. And then if you plug 3 pi over 2 and you get -1, you get negative. That's where the negative is. And I knew I was wrong because I knew this should be vertical in nature, and the way it was coming out was looking horizontal. So, so 0, -1 ends up, it starts over here, and pi over 2 0 is here, and then pi is over here, but it's a negative value, so it ends up over here. 3 pi over 2 is down, but it's negative, so it ends up here. So this is what our cardioid looks like. And we want to know what's the slope of the curve, dy dx. By the way, slope of the curve, I feel like should be pretty easy to remember after parametrics. It's dy d theta over dx d theta. And don't try and memorize any of those equations that I went over the notes and told you not to memorize. So 0 is right, is over here actually. So we're looking for that slope. So I bet we should get like a negative slope. And pi ends up over here. So this is pi actually. You might think it's the opposite, but remember they had negative radius. So it looks like the slope should probably end up being the same, but one positive, one negative, just because they're on kind of like corresponding parts of the graph. So x equals r cosine theta. So that's going to be parentheses -1 plus sine theta, cosine theta. And y equals r sine theta, which would be -1 plus sine theta, sine theta. And I don't even think I'm going to do dy dx separately. I'm going to write an expression right here, dy dx. So derivative of the top with respect to theta is going to be -1 plus sine theta, cosine theta, plus sine theta. Derivative of that's going to be cosine theta, all over dx d theta. So it's going to be -1 plus sine theta, negative sine theta, plus cosine theta times cosine theta. So that's the derivative. So now we're going to plug theta equals 0 into it. And so this is just a little tedious. Got to be careful. J word. So if you plug 0 in, sine of 0 is 0. So it's going to be -1 times cosine of 0 is 1. Plus, that's going to be 0 times 1 over, that's going to be -1 times 0 plus 1 times 1. So it's going to be -1 over 1 is -1. So that's the slope dy dx at theta equals 0. So it might be good to label your answer. And then dy dx when theta equals pi, I bet it's going to be +1. So remember, pi ends up over here. Looks like kind of like the same slope, but upside down. So if you plug pi in, sine of pi is 0, so you get -1. Cosine of pi is -1, plus sine of pi is 0 times -1 over negative 1 times 0 plus negative 1 times negative 1. So those terms drop out. We get positive 1 over positive 1, and sure enough, we get positive 1. So that's how you do it. And it makes sense with the graph, which you weren't required to do, but I think was pretty helpful. 40, r equals cosine 2 theta, and we want to know the angles at 0, plus or minus pi over 2, and pi. Now, let's do a sketch of this. You should recognize this is a rose curve, right? And we usually don't do tables for these. You usually try to figure out what the tips are. So that would be plus or minus 1 equals cosine 2 theta. So 2 theta equals 1 does cosine equal plus or minus 1? 0 plus pi k. Theta equals 0 plus pi over 2k. So theta equals 0, pi over 2, pi, 3 pi over 2, 2 pi. Now we expect to get 4 petals. It's an even number on the inside, right? Has a radius of 1. So if we do a quick sketch of this, so I should have done that light and dash, but pi over 2. So there's going to be a petal here, 0, pi over 2, 3 pi over 2, 2 pi. But the first one is positive. We should draw the angles that split the angles in half where the tips are, because that's going to be where the edges of the petals are. So this is the first one. So it's probably going to go like this, first one, and then it's going to go down into this. So this is going to be the second one, and then it's going to go into this one. That's going to be the third one, and it's going to go into this one. That's going to be the fourth one, and it's going to finish it off. So this quick sketch, we want the angles at 0, which looks like a vertical tangent, pi over 2, which looks like a, actually is down here, looks like a horizontal tangent, pi, which looks like another vertical tangent, and a negative pi, which would be backwards, but ends up here. That's that fourth one. So it looks like we should get 2 zero slopes and 2 undefined slopes. And that's just good enough ahead of time. So x equals r cosine theta. So that's going to be cosine 2 theta, cosine theta, which you cannot combine those together. And y equals r sine theta. So that's going to be cosine 2 theta sine theta. So then dy dx equals, so on the top it's going to be cosine 2 theta times your sine is cosine, plus sine times your cosine is going to be negative sine 2 theta, and then you get a chain rule, you get an extra 2 outside. On the bottom you have dx d theta, so it's going to be cosine 2 theta, derivative of cosine's negative sine, plus cosine theta times derivative of cosine 2 theta is going to be negative 2 sine theta, and then again another chain rule there. Okay, so we're going to use this for all of them. So dy dx when theta equals 0, which we expect to be infinitely big, it's going to be 1 times 1 plus 0 times 0, and bottom is going to be 1 times 0 plus, that's going to be 1 times 0. So we get 1 over 0, which is undefined, just like we thought. So that's dy dx when theta equals 0. So it's good to label your answers. Label the work, label your answers. So I'm going to do it for theta equals pi over 2, which actually is down here. So it should be a 0 slope. Let's see, cosine of pi is negative 1. Cosine of pi over 2 is 0. Plus sine of pi over 2 is 1 times, and cosine of sine of pi is 0. And then on the bottom, we get cosine of pi is -1, and sine of pi over 2 is +1, but there's an extra negative already. Plus cosine pi over 2 is 0 times sine of pi. That would give you a -2, right? So you get 0 over 1, which is 0. Good. That's what we thought would happen. Okay, and then negative pi over 2, which we expect to also turn out to be 0. Cosine of negative pi would be -1. Cosine of negative pi over 2 would be 0. Plus sine of negative pi over 2 would be -1. But then sine of negative pi would be 0. On the bottom, cosine of negative pi over 2 would be -1. Sine of negative pi over 2 would be 0, plus cosine of negative pi over 2 would be 0. Sine of negative pi would be, sine of negative pi would also be 0. I think up here I might have messed that up. Sine of pi, that should have been 0 too. I didn't change my answer. Now this one's kind of weird. Did we make a mistake? Is it 0? Okay, coming back to this, sine of negative pi over 2 would be 1, and it would be negative, but there's already another negative, so it should be 0 over -1, which is 0. Okay, matches the picture. Last one, we're going to do pi, which I think should be even easier. So cosine of 2 pi is 1. Cosine of pi is -1. Sine of pi is 0. Sine of 2 pi is 0. Over cosine of 2 pi is 1. Sine of pi is 0. Plus cosine of pi is -1. And sine of -2 pi is 0. So we're going to get -1 over 0, which is undefined, which makes sense. Vertical tangent at pi. So label your answers, label your work, show your work. Don't use those formulas. They would not help you. They would give you all the same stuff we got, make it take longer, probably add mistakes. Okay, last problem. It's going to be 41. Now, this one came with a picture. I went ahead and sketched it. The picture, I feel like, makes sense. It's just good practice of a shape. I feel like we haven't done too much on homework. So, this is not a cardioid. So this is like a limacon with an inner loop or convex or whatever. It's okay if you don't remember. We could just we could do a quick table. Theta r 0, pi over 2, pi, 3 pi over 2, 2 pi. So sine of 0 is 0, so it's going to be 2. Sine of pi over 2 is 1, so it's going to be -1. Sine of pi is 0, so it's going to be 2. Sine of 3 pi over 2 is going to be -1, so it's going to be 5. Back to 2. So the biggest angle is downward. So if you're going to sketch this and you haven't done it yet, you're going to need more room below. If you're trying to make use of your paper and not waste a lot of space. So 0, 2 is right here. Pi over 2 -1 is right here. Pi 2 is right here. 3 pi over 2 would be down, and it's 5. And 2 pi are back to here. Now, see this? This tells you it has an inner loop because it's down here in the middle of it. Like all these limacons, including cardioids, have this kind of look. And then some go up here, convex, some go right here, cardioid, and if it ends up down here, it's for sure going to go through the origin like that. Now my sketch isn't really that good. It should be fatter and plumper and rounder which kind of makes a difference if you're using the sketch to help you kind of figure out answers. Now we're doing it at, now the picture, they gave you this picture, and then I think they labeled points for you, and you're trying to find the slopes at those points. So I think we got 4 points to find the slope at. Now from the picture, that's going to be flat. That's going to be 0. That's going to be 0. This, I think, is going to have a positive slope, and this is going to have a negative slope. Probably the same values, but one's positive, one's negative. So we have a pretty good idea what the answer is going to be. So let's do the work. X equals r cosine theta. So that's going to be 2 minus 3 sine theta, cosine theta. And y equals r sine theta. So it's going to be 2 minus 3 sine theta, sine theta. Okay, then we're going to figure out what dy dx is. It's going to be dy d theta over dx d theta. So I don't need formulas or anything to do that. It's just going to be a waste of time. And I guarantee you're going to make mistakes. And you don't need to make. So on the top, I'm going to do product rule. So derivative sine is cosine plus sine times the derivative of that. It's going to be negative 3 cosine theta. All over the bottom is going to be dx d theta. So it's going to be 2 minus 3 sine theta times negative sine theta plus cosine theta times negative 3 cosine theta. So there it is. There's dy dx for any angle on this curve. So now this is where we got to wade through the details. We already know roughly what the answer should be. So we do 0. Sine of 0 is 0, so you get a 2 times 1 plus 0 times negative 3 over 2 times 0 plus cosine of 0 is 1, negative 3. So those terms drop out. You get 2 over negative 3. So negative 2/3. If anything, it feels about right. It's definitely negative. And, you know, it's not super steep or super flat. It seems kind of right in the middle. But it seems right. We could do the other one that I think at pi is going to give us the same thing, probably positive 2/3. Let's try it. Sine pi is 0, so you get 2. Cosine pi is negative 1 plus sine of pi is 0, and cosine of pi is negative 1, so it's going to be positive 3 over 2, and it's going to be 0 plus negative 1 times positive 3. So those drop out. So you get negative 2 over negative 3, and sure enough, positive 2/3. Just like I thought would probably happen. Okay. So now we need to do it for these other ones that should come out to 0. So we're going to do it for pi over 2. So sine pi over 2 is 1. So it's going to be negative 1. Cosine pi over 2 is 0 plus 1 times 0 over negative 1 times negative 1 plus 0 times 0. So we get 0 over positive 1, which is 0. Okay, totally makes sense with the picture. Okay, and then one last one. Dy dx theta equals negative, or 3 pi over 2. 3 pi over 2. So sine of 3 pi over 2 is negative 1, so it's going to be 5 times 0 plus negative 1 times 0 over 5 times positive 1 plus 0 times 0. So it turns out to be 0 over 5, which is 0. label your answers, label your work. Should be easy for someone to figure out what that's for. So there you go. Little tedious work there at the end, but I tried to cut out a little bit of the work. Okay,